Very good morning, friends. Today's subject of discussion is limit test for lead. Recently, you might have come across the Maggie case and the total materials that was in the market was taken back from the manufacturer. This is because of the fact that it contained the lead in more quantity than the prescribed limits. If it is present in more quantity, it has deleterious and toxic effects. That's why lead should be within the limit of the prescription of the Indian pharmacopoeia. Now you can appreciate the use of limit test or application of limit test for lead. The limit test for lead is based upon the reaction between the lead present in the trace amounts as impurity in the given substance with the reagent diphenyl thiocarbazone, which is also called as dithiazone. The lead in diphenyl thiocarbazone reacts together and gives rise to dithiazone complex in alkaline medium. Dithiazone in chloroform extracts lead from the alkaline aqueous solution and forms lead dithiazone complex, which is having violet color. Here the reaction is this: diphenyl thiocarbazone, phenyl diphenyl thiocarbazone is the reagent which you use. It reacts with the lead present in the given substance and it forms the complex. This complex is dithiazone complex or lead dithiazone complex to be precise. We take dithiazone in the chloroform layer and we dissolve the substance in the water, and the lead present in the given substance gets extracted with the dithiazone dissolved in chloroform and it formed dithiazone complex, lead dithiazone complex. Dithiazone, when we dissolve in chloroform, it gives green coloration. And when it extracts the lead in the aqueous solution to the chloroform solution, it forms dithiazone complex, which is violet in color, or else it is already green in color. The product what we get is violet in color. The green and violet color combines together to give violet red color. First of all, the dithiazone, when it is dissolved in chloroform, it has a green complex, green coloration, which is shown here. When it extracts the lead into this chloroform layer from the aqueous layer, it gives violet red color. This formation of the violet red color we compare with the coloration produced by using the standard solution of lead. If the coloration produced in the test solution is lesser than that of the standard solution, then it passes the limit test. Here we are utilizing the reaction of dithiazone with lead present in the given substance as impurity to give lead dithiazone complex, which give a colored product. Let us look into the procedure what we adopt. We take test solution, Nessler cylinder 1, standard solution, Nessler cylinder. We add the required quantity of the sample as prescribed by the Indian Pharmacopoeia and dissolve in water and transfer into a separating funnel. In the standard solution, we take this lead standard solution which contains 1 part per million lead in it. This is equivalent to the amount of lead permitted in substance being examined in the separating funnel. To this test solution and standard solution, we add 6 ml of ammonium citrate solution which is specially prepared for carrying out the limit test for lead in both the test and standard solution. The ammonium citrate which we use may also contain lead and the lead present in it should be removed. That's why it should be specially prepared for the limit test for lead. Then we add 2 ml of hydroxylamine hydrochloride solution followed by 2 drops of phenol red solution. Again, it is followed by the addition of alkaline. This alkaline is added. Addition of strong ammonia solution to make this above mixture alkaline. When we add ammonia, the temperature may increase. That's why if it is necessary, we have to cool it. Then we add 2 ml of potassium cyanide solution, which is also specially prepared, means which is devoid from lead. Why this ammonium citrate, hydroxylamine chloride and potassium cyanide to be added? This is added to extract and discard the interfering metal ions at optimum pH in the complex form. It reacts ammonium citrate, hydroxylamine chloride and potassium cyanide. They combine with other metals other than the lead and it forms the complex. And as it has formed the complex, that complex do not get extracted into the dithiazone preparation, the reagent which we use for knowing the limit test for lead. Then the solution which is prepared above is immediately extracted with several quantities of dithiazone solution, each of 5 ml. The other impurities are in the complex form. The lead is not in the complex form. That lead which is present in the aqueous solution get extracted into the dithiazone extraction solution. In this dithiazone solution, which is in chloroform, it extracts the lead from the aqueous layer into the dithiazone extraction solution which is prepared in the chloroform. It extracts that and it forms violet red coloration. The organic layer becomes violet red as shown in the first slide. We should extract such that all the lead present in it gets extracted in dithiazone. How many times we should extract? Until the chloroform layer will not become violet red color, it remains green in color. Means all the lead present in the aqueous layer has got extracted into the chloroform layer. Then we have to combine all the dithiazone extract which is violet red in color and shake for 30 seconds with 30 ml of 1% volume by volume solution of nitric acid. When we extract with it, the lead present as a lead dithiazone complex in the chloroform layer gets back into the aqueous layer as lead nitrate. Means the organic layer coloration from as turned back from violet color to green color. This lead which is extracted back into aqueous layer is lead nitrate. Means whatever has been taken in the extracted in the organic layer comes back into the aqueous layer in acidic condition as lead nitrate. We take this aqueous layer and discard the chloroform layer, and to this aqueous layer in which the lead is present as lead nitrate, we add 5 ml of standard dithiazone solution to both the standard and the test solution. The standard solution extract back lead from the lead nitrate and it forms lead dithiazone complex, and that gives the coloration. We keep it aside for 30 minutes and we observe the violet red color formed in the organic layer. Then we compare that color with the standard solution. The violet red color, if formed, intensity is lesser than that of the standard solution, then it passed the limit test for lead. That indicates the lead is within the prescribed limit, that is less than 1 part per million. Here you see it will be green in color before. When I add 5 ml of this dithiazone solution, after 30 minutes it forms violet red color as it is shown here. Means the lead nitrate which is present in the aqueous solution gets extracted into the chloroform layer in which dithiazone is present and form dithiazone complex, and it gets converted into violet red color. The coloration which is produced in the test solution is lesser than that of the standard solution, then it passes the limit test. This is how we perform the limit test for lead. And in the next presentation, we will be discussing about the preparation of these reagents. These reagents are prepared specially for the limit test for lead because of the fact that the materials which we use in the process may also contain lead. We have to make it free from lead and then use it. How it is done, we will discuss in the next class. Till then, have a nice day.